Expansion theory. What is expansion theory? In simple terms, expansion theory is the idea that the universe is expanding. In the early 1800s, German astronomer Heinrich Olbers argued that the universe must be finite. If the universe were indeed infinite, Olbers claimed that if you looked in any particular direction, your eye would eventually catch a star. Although the apparent size of a star in the sky becomes smaller as the distance of the star increases, the brightness of the smaller surface remains a constant. Therefore, in Heinrich's mind, if the universe were infinite, the whole surface of the night sky should be as bright as a star. Obviously, there are dark areas in the sky, so in his mind the universe must have been finite. However, when Isaac Newton discovered the laws of gravity, he was able to deduce that gravity is always attractive, meaning that every object in the universe attracts to every other object. If the universe truly were finite, the attractive forces of all the objects in the universe should have caused the entire universe to collapse on itself. This clearly has not happened, and so astronomers were presented with a paradox. When an object moves away from us, its light waves are stretched into lower frequencies or longer wavelengths. We say that the light is redshifted. In 1929, Edward Hubble measured the redshifts of a number of distant galaxies. He also measured their relative distance by measuring the brightness of various stars that existed in each galaxy. When he plotted redshifts against relative distance, he found that the redshifts of distant galaxies increased as a linear function of their distance. The only explanation for this observation was that the universe was expanding. The scientists understood that the universe was expanding. They simultaneously realized that the universe would have been smaller at some point. At some point, the entire universe would have been a single point. This point, later called the Big Bang, was the beginning of the universe as we know it today. The expanding universe is finite in both time and space. The universe has been expanding from the moment of its creation. This is the reason it did not collapse immediately after it was created. The universe is in a constant state of change. The expanding universe laid to rest the paradoxes that troubled astronomers in ancient times. The equation of the expanding universe has three possible solutions, each of which predicts a different fate for the universe as a whole. Which fate will ultimately befall our universe can be determined by measuring how fast the universe expands relative to how much matter the universe contains. The three possible types of expanding universes are called open, flat, and closed universes. If the universe were open, it would expand forever. If the universe were flat, it would also expand forever, but the expansion rate would slow to zero after an infinite amount of time. If the universe were closed, it would eventually stop expanding and recollapse on itself, possibly leading to another second Big Bang. In all three cases, the universe slows, and the force that causes the slowing is gravity. A common analogy used to explain these three types of universes is to consider a spaceship being launched from the surface of the Earth. If the spaceship does not have enough speed to escape the Earth's gravity, it will eventually fall back to Earth. This shows a closed universe that recollapses. If the spaceship is given enough speed so that it can escape the Earth's atmosphere, then at an infinite distance away from Earth, it will come to a stop. This shows a flat universe. And lastly, if a spaceship is launched with more than enough energy to escape, it will always have some speed, even when it is an infinite distance away. This explains an open universe. Without expansion theory, we would have no idea how our universe was created or how we came to be here. Expansion theory fills in a little bit of that huge puzzle that scientists around the world are trying to answer.